Remember that in geometry we have a plane, which is a two-dimensional surface, and pretty much everything that we do in this class is going to be geometry on a plane. We're looking at doing geometry on a flat two-dimensional surface. And anything that we draw in that flat two-dimensional surface we call a plane figure. So figure just means it's some sort of shape or drawing or something in that plane. A polygon is a specific type of plane figure. It's one that is closed, meaning that it's not open. So for example, that would be an open figure. So imagine if it's a fence, things could get out of that. A closed figure would be a fence where, if there were, say, cows in it, it wouldn't be able to get out. So it has to be closed in order to be a polygon. And a polygon also has a couple more properties. So it's formed by 3 or more line segments. We call those sides. So we need to have at least 3. I mean, if you imagine trying to make a closed figure with only 2 sides, assuming that those are straight lines, well, we could do something like that. That's not a figure, that's an angle. If we want to make a closed figure, we need at least 1 more side. So the bare minimum that we can have in terms of number of sides of polygons is 3. So a triangle is the smallest number of sides you can have in a shape for a plane figure. Each side intersects exactly 2 sides, 2 and only 2, no more than 2, 1 at each endpoint. So if we say, for example, look at this side right here in blue, we've got an endpoint over here and an endpoint over here, and at those 2 endpoints, it intersects these 2 red lines. So it intersects 2 other sides, 1 at each endpoint. And also, we need to have it so that these points are not collinear. So that no 2 sides with a common endpoint are collinear. So this is just saying, like, if we had, say, a point right here in the middle of the side, we wouldn't say that this thing and this side are 2 different sides. They're all on the same line. So we would just say that that's 1 side, and it just happens to have a point in the middle. Each endpoint of the side is called a vertex of the polygon. So the vertex is just a corner. Plural vertex is vertices. So the triangle has 3 vertices. It has 3 corners to it. Again, vertex is the singular, vertices is plural. A polygon can be named by listing the vertices in consecutive order. So if we want to name this polygon, what we do is we just pick a starting point, doesn't matter where. I'm going to pick A to start with because it's A and that's the first letter of the alphabet. And then we just have to go around the shape. And it doesn't matter which direction we go in either. So if I'm going to start at A, then I could go around this direction. I could name this pentagon A, B, C, D, E. All right, and so the fact that there are 5 letters there, 5 points, 5 vertices, tells you that it's a pentagon. But again, we could have done pretty much anything else. We could have started at C, for example, and maybe gone around this way. So it would be perfectly legitimate to call this pentagon C, B, A, E, D. One thing we cannot do is just jump across. So like if I were to say, call this B, A, E, D, C, this is incorrect because the vertices here are not listed in order going around the shape. So again, it doesn't matter where you start, it doesn't matter which direction you go, just make sure that you aren't jumping around the shape. Make sure that you list consecutive vertices. That means vertices that are all in a row. Okay, polygon is going to be something called a convex polygon. A convex polygon is one that has no kind of indents in it. The kind of official definition of this is one that has no lines that go inside the polygon. So for example, on the right here, you see this line. If we draw that line on this side right here and extend that line, it goes into the shape. Whereas on the left side, that doesn't happen anywhere. No matter what side we extend on, it's not going to cut into the shape itself. So one where it does happen, like on the right, we call this a non-convex, or more commonly, a concave polygon. Now the way that I like to remember this is that a concave polygon has a cave in it. So looking at the shape on the right, there's this indent that goes into the shape. That makes kind of a cave inside the shape, and so that's a concave shape. And then convex is just the other one. Convex does not have a cave in it. Let's look at example 1. For part A, determine whether this is, well, I guess first of all we have to determine if it's a polygon or not, and whether it's concave or convex. So for part A, this is a polygon. It's closed, and it doesn't have any curved sides to it. Polygons need to have straight sides. We don't say it's a polygon if there's any kind of curvature to it. So part A is definitely a polygon, but it is a concave polygon. You can look at these two sides here. That one on the right, you can see indents. It also happens on the left. Or if you want the more formal definition, if we were to say extend one of these lines, it would cut into the shape. So that is a concave shape. B is a polygon. It is closed, and it has all straight sides. That's fine. So that is a polygon, and it is a convex polygon. So there is no indent into that shape for part B. C is not a polygon because it has curved sides. And D is a polygon. It's closed. It has all straight sides. And it's a concave polygon because we've got these 4 little indents into the shape. So that is a concave shape. A shape that has all sides congruent. So say, for example, a square. So square has all 4 sides exactly the same. We call that an equilateral shape. You know, we can have any type of shape. Well, it's not the best pentagon in the world, but you can imagine if all 5 of those sides were congruent, that would be called an equilateral pentagon. We could, of course, have a triangle. This triangle has all 3 sides exactly the same, and so we call all of those equilateral shapes. So the first part of the word here, EQUI, it looks a lot like the word equals, and then lateral is kind of the word that we use for the sides of the shape. So lateral is sides, equi is equal. So this is a shape that has equal sides. Equiangular, well, look at the word angular in there, that's angles. And then EQUI, that means equal. So this is a shape that has all equal angles. So for example, we could have a rectangle. So a rectangle has 4 right angles like this. We could, of course, have a triangle that has equal angles as well. And we could have any kind of shape as long as it has all the angles equal. We can call this an equiangular shape. Now, if we have both of those, if all the sides and all the angles are congruent, then we have something that is both equilateral and equiangular. We say that that's a regular polygon. So both equilateral and equiangular. We have some special names for shapes that have any number of sides from 3 to 12. Beyond that, we just call it an n-gon, so n being the number of sides. So let's actually jump below the table. It says the term n-gon, where n is the number of polygon sides, can be used to name a polygon. So for example, a polygon with 14 sides, we would just call it a 14-gon. If it has 18 sides, we'd call it an 18-gon. If it has 1,000 sides, we'd call it a 1,000-gon. But for the shapes that have we can't have one with one, that have 3 through 12 sides, we have special names for those. So 4 sides, you might be thinking square or rectangle, but actually that is not the general term. So a square and a rectangle, those are very specific types of 4-sided shapes. The general term for just any shape that has 4 sides is a quadrilateral. So quad means 4, and then lateral, again, like we talked about before, with equilateral, that has to do with the sides. 5, think about the government building, the Pentagon. So penta means 5, and then gon is the word that we use for polygons. By the way, poly, in the word polygon, poly means many. So polygon just means a many-sided shape. So we use the word polygon to describe any shape that has any number of sides. All right, a 6-sided shape, we call this a hexagon. 7-sided shape, that's called a heptagon. 8-sided shape, think of like a stop sign. It's an octagon. Nine-sided shape is a nonagon, N-O-N. 10 sides is a decagon. So the prefix DEC means 10. Think of like the word decimal. So the word decimal, the first part of that is 10 because we use a base 10 number system. So each place value, it has some power of 10. So we have the ones place, tens place, hundreds place. These are all multiples of 10. Then a 12-sided shape. We're going to skip over 11 because we don't really care about 11. But a 12-sided shape is a dodecagon. So do means 2, dec means 10, so 2 and 10 is 12. Just for the sake of completeness, if you want to know what an 11-sided shape is called, it's an undecagon. So un means 1, dec is 10, 1 and 10 is 11. Anything beyond that, we just again call it an n-gon, where n is the number of sides that it has. Let's look at example 2. Classify the polygon by the number of sides, then tell whether it is equilateral, equiangular, or regular. So this first one has 6 sides, which means it's a hexagon. Now this really looks like it has all equal sides, and it really looks like it has all equal angles, so it's going to be very tempting to say that this is a regular hexagon. A regular hexagon, again, would have all sides the same and all angles the same. But in geometry, when we're looking at pictures, you never make an assumption based on the picture. So unless there are markings on the picture that indicate that sides are actually the same, or unless there are angles that indicate, markings on the angles that indicate all the angles are the same, you do not assume that it is a regular shape, or you don't assume anything about it unless it's marked. So like for part C, all of these sides here are all marked the same. These little red marks here all mean that that's congruent. And so this one we could say is equilateral because all the sides are marked congruent. For part A though, there are no markings there. There's no indication of whether or not those are actually the same length. So they look like they are, but you know, maybe one has a length of like 100 and the other has a length of 99.99999. You know, they could be very, very close, so close that we just can't see that they're not the same. So we only say that they're going to be the same if they are actually marked. So this is, we cannot say, we do not have enough information to say that this is equilateral or equiangular or regular. On part B, this has 4 sides, so this is a quadrilateral. And again, there's no markings on here. So it's not marked, there are no markings congruent. You know, it looks like this side is congruent to this side. It looks like this side is congruent to this side. But we were not given that. There's nothing in the instructions. There were no markings on the picture or anything like that. So we cannot make any assumptions about that. For part C though, this one has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So that is a decagon. And as far as equilateral or equiangular, well, all the sides are marked congruent, so it is equilateral. All the angles are marked congruent, so it is equiangular. Or, well, they are all marked as 36 degrees, so that means they're all the same. And so that means that this is a regular shape. So if a shape is both equilateral and equiangular, then it is a, let's try that again, then it is a regular shape. And the last example. A table is shaped like a regular hexagon. Let's draw a picture. Of course, my picture is not perfectly regular, but we'll just pretend. It says one side of the table has a length of 3x plus 6. And another side of the table has a length of 4x minus 2. Find the length of a side. Now, it doesn't really matter which one you write where, because again, these all 6 are congruent. That's a consequence of it being a regular hexagon. All the sides are congruent to each other. So I could have written that 3x plus 6 and the 4x minus 2 anywhere I wanted. Well, now that I see that one side is 3x plus 6, another side is 4x minus 2, and it's a regular shape, so these are all the same, that means I can just set these equal to each other. So let's do just that, and then solve. In this equation, I've got both x's on the left and right side. I've got numbers on both the left and right side. So what I want to do to solve this is get everything with an x on one side of the equation and everything without an x on the other side of the equation. There are multiple ways to do this, but what I'm going to do is I'm going to start by subtracting 3x from both sides. 4x minus 3x is x. Now I've got everything with an x on the right side, so let's get everything without an x on the left side. And we get an x value of 8. Now that is not the answer. So it told us to find the length of a side. It did not tell us to find x. We have to find x in order to get the answer, but we're not done yet. So in order to find the actual length of the side, we need to take this number for x and plug it back into either one of these expressions. It doesn't matter which one. So 4 times 8 minus 2. 4 times 8 is 32. Minus 2 gives us a side length of 30.